So, let us look at NumPy arrays in bit more detail. This is efficient implementation of list. So, we should not use list for our course because we want to do things fast. Okay. Computer science data are not of the same type, and there you sacrifice speed for some processing. So, here we want to make it efficient, and data type, data size are all fixed. So, number of elements in the array is fixed, it cannot be changed. Okay. Data type can be of int, float or string, but it is one type. There are exceptions, but in this course I will not discuss it. So, either it is of integer type or float type or string type. We also not want to deal with string. So, basically float and int, and that is what we will do. Okay. And so, it is a homogeneous data type, and that is what makes it fast, and data size is also fixed. So, I will give an example after this. So, this is how we define an array. So, the array is a function, array with, so a small bracket means function, a function arguments will go inside. So, array is a function whose argument is a list, but these are of integer type 1, 2. Is that clear? So, array always will come with small brackets, not with large bracket. Now, if I just say y is a variable which contains arrays. So, it will just print this. Now, you can look at the type of the elements. So, here my elements are y0 and y1. y0 is the first element and y1 is the second element, and if to get the type I say d type, okay, data type, d for data, and these are integer 64. So, this is out 64 bit. Okay. This is what is stored here. Now, y star 2 will multiply each element by 2. I can get the size of this array, is number of elements is 2, length is also gives you same answer. I can get a new array z as y plus 3. So, 3 will be added to each element. So, most operations like addition, subtraction, division and so on will be acting on each element of the array. So, the array answer is 4, 5 because just add 3 to each element. Okay. Now, what if you put mixed input? So, you may be saying some integer, some float, we will focus only on that and not on string. So, if I have mixed input, so my input for array y is 1.0, 2. So, this is float, means real, float is real, floating point, so it is real, 2 is integer. Now, if I say d type, so it gives you both float. So, what has it done? It has converted that 1 rather 2.0 2 to 2.0. So, it will convert it automatically. So, it makes all the data as same type, that is what makes it efficient. List will not do it, list will keep one as float, other one as int, which I showed in the last class. Okay. So, that is the difference between list and array. What if I put both of them as 1.0, 2.0? This is straightforward, it should be both float 64, it is 64 bit, okay, it is a double. Float 64 is same as double of C. So, let us do some more with now this is a 2D array, means there is a square bracket, within that there are 2 elements with square brackets. So, it is 0, 1, 1, 0, it is a matrix. So, if I say x, then I will get the same thing. Now, I can do the determinant of x. So, I get answer is -1. Eigenvalue and eigenvectors can be obtained by function EIG. It will give you eigenvalues are here and eigenvectors are 2 of them. So, it is a 2D array, you see. The first is the first eigenvector and the second element is the second eigenvector. Now, this array is of inhomogeneous type, you see, it has 2 elements. This is the first element, which is a vector with 2, 1, and this is an array with 2, 2. So, it has 4 entries and it has 1 entry, it is an array. This is inhomogeneous, we do not want to start working on this, but Python will output this. So, Python is very kind of is a loose language where data can be of different types, it will manipulate it, it gives you flexibility, but of course, it makes it slow. A little bit look at how to access arrays, array elements. So, how to access array elements? So, in 1D straightforward, 1D is like list. So, y0, y1, y2 like that, but in 2D you have to access like this. So, again starts with 0. So, 0 is a valid address. So, 0 comma 0 is the first element of this 2D array, 0 comma 1. So, this is a row and this is called column. So, the second index is the column index and the first index is the row index. Is that clear? So, this row 0 and row 1. So, that is the first index, row 0, row 1, and this is a column, column 0, column 1. So, column 0 is here, right, and column 1 is here. So, it can be bigger arrays, it is a 2D, or we can also do 3D. 3D will have 3 indices I, j, k. 3D is not a matrix, 3D is an array. Like in this room, I want to represent position of a point, then it is going to be x, y, z, and we can represent by 3D array, or it can also be 4D, 5D, whatever dimension you want. It programming languages created and Python does it too. So, we can access the 0 comma 1, which will be this element. Okay, remember it was 0 1 1 0, so it's correct, this is the answer 1, print. Okay. Now, we can also access this element by putting 2 bracket 0 bracket 1, this gives the same answer. So, this saves you a bit of writing, but you can use this as well. Let us look at this eigen function again. So, I can assign this answer to a array y, because it gives an array eig returns an array. So, if I say y, so it is going to give me the array. I want to access some element, let us say I want to access this guy 1.0. How do I access it? This is an array y, y is 0 or 1, y is 0 comma, will it work 0 comma 0? It turns out it does not work, because it is a inhomogeneous array. So, this will not work and it gives error like this, it will come in your screen. So, what you have to do is you have to say 0 bracket 0 bracket. So, if you say 0, put a bracket here, put a bracket here, it will work like this. So, y11 will give you, in fact now this is another example, y11 will be what? So, this is 0, this is 1, but 11 will give you this one. This is y0 and this whole thing is y1. So, it is a structure of structure, if you know this C. So, let us write this. So, for this example, y0 is a structure which is that 1 minus 1, is it correct? 1 minus 1, and y1 is the 2D array. Now, I want to get y11. So, if I say y11, what will I get? So, this consists of 2 of these. So, I will get here, and if you want to go within that, so I want to get here, then I have to put this y111 in 3 levels. So, you go in a building, then you go inside the one corridor, then go inside a room, and this part of structure is not a, actually this is not an array really in strict sense, it is a structure which has sub arrays inside, but do not worry too much about it. I just wanted to illustrate that addressing has to be carefully done. For you, you just focus on matrices and arrays which are 3 by 3, 5 cube like that. Okay. So, but if you want to access data from these kind of objects, then you need to know how to do it. So, we can also do operations of mathematical operations. So, Numpy, so it PyLab, Python lab, Py for Python. Python library has square root as a function. So, if I do square root of this, I will get this. It is an array, square root will act on each element. Similarly, I can add 2 arrays y plus z. So, you will add element by element. But what if I do y star z, what will I get? It is not a matrix multiplication or array multiplication, it is element by element multiplication. If I take matrix A and matrix B, I say A star B, it is just going to do element by element multiplication, it is not going to do matrix multiplication. Matrix multiplication you have to write your own, but rather it is there, but it is not A star B. So, one has to be careful this kind of in this operation. This is a dot product, if you like. It is not a complex number, but it is a dot product. Well, actually it is not a dot product, I apologize. It is not adding things, but it is just multiplying, it is just multiplication of element by element, that is what you should say. It is not a dot product, I take back. These are very useful things, especially when I want to create an array, I do not know the entries, so I am not going to write like this. So, suppose I know that it is 10 array of 10 elements. So, you say 0s 10, right, you just say 0s 10, all entries will be zeros and 0s 10, this is a useful function. Or you can say I start with 0s 10 or 0s 4. So, it will create an array and on that I will operate. We can create an empty array or with arrays with ones. This is a range function which I described earlier. So, 0, 3 will give you equispaced numbers 1, 0, 1, 2, not 3. Yeah. It has no name. If you like, you can just say x equal to. If you say x equal to, then x will get that entry. It just gives the output. It's the same thing. So it's same except it will act on arrays. So it gives an array, not list. So that gives a list and this gives an array. Sometimes you want arrays, so it will give arrays. There is one more useful function called rand. So rand will give random numbers between 0 and 1. So these are random numbers with four entries, 4 elements. If I don't put anything here, it will give you one number. But if you want to generate 100 random numbers, you can just do it. Like linspace was a bit confusing in the last class. So linspace, if I want linear space points between 1 and 2, including 1 and 2, but 3 points, then the middle point must be 0.5, 1.5. So this is number of elements in that array 3 and starting and the end values. So this will give you, so in one line, it just gives in one line, linspace gives that function. We can also, with 5 elements is going to be this. We can convert a list to an array. So how do you convert a list to an array? So this is a list, right, x equal to 3, 4 is a list. List will not allow you to do square root. Square root is not possible on a list. List could have string and so on. So you say, well, I don't know how to do square root of, I mean it's impossible to do square root of a list. But I can convert that to a NumPy array by saying that array x. So y will be a NumPy array on which you can do square root and all the math operations. That's about it. So this for NumPy arrays, which is going to be a key part of our course. All the things which you will be using NumPy. You have to be conversant with how to use NumPy.